Well, sometimes we don't see that difference because architecture right now, it's practically, it's practically all the same, even though if a conventional building is being designed as a modern architecture project. And green building actually has differences in this case. And the difference is that sometimes when we go inside of a building that it's LEED certified, are differences that we practically don't see. We don't see them, but they're there, or maybe we don't look carefully. And these things, or the difference between a conventional building and a LEED certified building or a green building, is they are high performance buildings. These high performance buildings usually have at least 30% of water savings, and that's something we don't see. They have at least 20%, from 10 to 20% of energy saving. Some of them have a lot more. Some of them are even net zero. They don't use any energy, and they can produce more energy than they use or they demand, and actually sell that energy or give it to the electrical company so they can use that energy for other projects, for other buildings. And that's sometimes we don't even see that. Usually solar panels are all the way on the rooftop, and sometimes we can see it, sometimes we don't appreciate it, but it's there. And energy savings is not only, we don't only get that from solar panels, we get that from fixtures, we get that from a lot of automated systems that the building may have. They usually have a building automatic system that has everything that it's electrical, everything that it's mechanical, like the HVAC. All of this is connected to this system, where it's all automated, and it has schedules. For example, in offices, we can have an automated system, an automated panel, where you can give the panel a schedule to have lighting fixtures on from, say, 7 a.m. to 7 p.m. or 6 p.m. or 5 p.m. And that's peak hours of the office. So if it's not in between those hours, everything is turned off. Everything is, it's not wasting any energy during hours that there's no usage of the space, nor usage of the building. It all depends how the end users are going to be using this space. It could be an office, it could be a house, it could be the building, everything. So these are systems that we don't see because they're behind walls, they're in the ceiling, and we don't see this, but they're there. And when we have a LEED certification project, these projects have at least 10 to 20%, and you can go higher than that. It all depends. It all depends of the objectives of the project and the LEED certification level that the project is trying to achieve. We start with LEED certification, which is the basic one, and that one we can say that buildings have from 10 to 20% of energy savings and 30% of water savings. But if you go on if you go to silver, if you go to gold, if you go to platinum, there's projects that are LEED platinum, which are net zero. They don't use any energy at all. And all of this is behind the scenes. Everything is behind the walls, behind the ceilings, behind everything, but it's there. So these are things that makes green buildings different from conventional buildings. The way that you can see if a building is saving water is by its fixtures as well. These buildings usually use fixtures that have very, very low consumption. As I said before in one of my other lives, what I usually use for these types of buildings, I like to use fixtures for water saving that are less than 0 point something. For example, a water closet. I would use a water closet that has 0.8 and lower. I think that's the lowest one. You can use from 1.0 to 0.8, and that's major savings for the building. And for lavatory fixtures, what I usually go from 0.5 to 0.35, 25. So we're talking about major savings. I always like to use these fixtures because my objective with projects are having at least 50% of water savings. So it all depends. It all depends on what the objective is for the project, what the certification level is for the project. So these are things that we usually, if we're not aware of it, we don't see it, but they're there, and that's what makes these buildings different from conventional buildings. The other thing that we don't see, because this goes on when we are in construction, during construction, is waste diversion of these buildings. Yeah, waste diversion. Tomorrow I'll be sending you guys in my story some pictures. I'm out of town right now. I'm visiting a project that I have here in Mexico, and tomorrow I'll be on site, so I'll be taking lots of pictures and checking out how we are doing in this project, and checking out some installations and everything. So doing some commissioning, and I would be sharing that with you guys too. So as I was saying, waste diversion for these buildings, we don't see that as well because we are not there when the construction is being held. So these buildings save, or they divert, at least 75% of construction waste. And this is comparing to conventional buildings. So that's another thing that we don't see, but it's there. It's part of the process. It's one of the prerequisites. These prerequisites are they have to be met, so you can certify these type of buildings. And we usually have from 50 to 75% of waste diversion. We separate all of this waste during construction. We have our waste areas where we have everything separated, and then just get the service. So they will take all of this and divert it and use it for anything else, maybe making more steel bars, or we actually do donate what is of the wood. We donate wood, and that wood is reused for people that actually do work in the construction, or other people that use this wood for furniture, or for anything. They reuse it as biofuel. And what we do, and the purpose of this, it's stop taking all that waste, all that trash, and everything, plastic, metals, wood, concrete. Sometimes we have a lot of concrete crushed, and we reuse it on site. So all of this waste doesn't go to landfill. And we actually have all of that controlled during construction. And that's something that you go inside a building, you will never know, unless you're like me, checking out which building it's LEED certified, and how the building is performing and everything, but we usually don't even we don't look at that. But those are things that go on behind the scenes. And the other thing that is very important is human health and users' health. And the interiors are very well managed during construction and before construction, and before the user starts using these buildings, these spaces. We have a critical phase in construction when we close up the whole building. The whole building is closed up. And what we do is have all of these materials that that can absorb humidity, or they can absorb dirt or any other contaminant. What we do is cover them up, or have them in a specified area where nothing of this, or none of the humidity, or none of contaminants will get to these materials. And once they are installed, once they are placed, we have a procedure where we do this very carefully, especially when we're having drywall walls. We manage our insulation in a certain way that there is no contaminants. And why do we do this? Why am I telling you guys a little bit more of this? Is because we care for end users, and we care for them during construction, before construction, because before construction, when we are designing, when we are taking about the whole project, we check on the materials that we're going to use, that they have low VOCs. We check that these materials have very low contaminants, and we care for these materials before they are installed in the project. So it's a whole process. I've been in the whole process. It's just a way of managing this type of buildings. And besides the materials, we have furniture as well. We actually do look at furniture. Not all projects do the furniture thing, because there are some of them that are just core and shell. They don't have anything in the interior. They're warehouses. So these type of projects, they don't look over furnishing. But if their tenants are having offices inside of this building, then they ask for them to go about with this procedure. They don't have to. It's not an obligation for the tenant, but it's a recommendation. And if they want to go about with LEED certification for interiors, commercial interiors, then they have to go about and they have to check now their checklist, their objectives, the level that they want to to have for this space, for this office. So that's what we do. We give them a guide and how or what to use for their interiors, and we check on everything: materials, furniture, adhesives, paints, primers, everything, flooring, ceiling, insulation. My God, composite wood, everything. We look for everything, every single little thing that we check during the process. And it may seem like, oh my God, this is so much information. This is a lot of stuff. Well, yeah, it is a lot of stuff. But you know something? I love my job. I love what I do, and I love everything about it. You know, I love taking care of the environment by doing this, taking care of the end users by doing this. So, I mean, once you are in this, it's nothing. I mean, it's a piece of cake. You just, go with the flow and you understand everything. So, yeah, I was talking about interiors. And the other thing that we usually check for having healthier interiors for end users is the ventilation. We do check on ventilation and mechanical systems. These mechanical systems have very strict designs. What we do is go about with the design by the ASHRAE standards, ASHRAE 62.1 2010. I'm using 2010, but you can go from 2010 to the latest. I think it's 2017, the latest. So for LEED version 4 B4, you use 2010. For LEED version B4.1, you use 2016, if I'm not wrong. Somebody that knows about that, and please correct me if I'm wrong. So we do check on the mechanical design. We do check on filters. For warehouses, we use MERV 8 filters. For offices, we use at least MERV 13. And this is, I know this is kind of technical for some of you, but these filters have like little pores where all the contaminants, and it all depends how big the contaminant, because they do have like their sizes and diameters. It's what the filter will let inside the system. So we always check that we are complying with these kind of filters for mechanical systems, and that we are complying with. I usually use for my projects sensors, CO2 sensors, or any other contaminant sensor that you can get those like in Amazon or anywhere, and they tell you how many contaminants are there in the interior. What we also do is have VOC testing before the end user starts, or goes inside the building and starts working in offices or starts working in the building. We check for total VOCs so that these interiors are adequate for end users. They're healthier for end users. And all of our mechanical systems for LEED, they need to have outdoor air. They have to have an intake of outdoor air, and this makes the quality of the ventilation and the quality of the HVAC system, it makes it better. It makes it healthier for users. Not having only mechanical system, but having that injection of natural air. And we usually, when the area is not that contaminated, the air is not contaminated, we like to use both, which is natural ventilation. We design for natural ventilation and mechanical. But if the area is very contaminated, if the city is very contaminated, I've had cities that are very contaminated, and we can't, even if we want to, we can't have any natural ventilation. So we need to have mechanical ventilation, but we go about all of these steps and all of these procedures to have the best air for end users in these projects. And this is another thing that we don't see. If we're not aware of this, when we go inside a building, we might not see it. We're not aware of it, but it's there. It's a process. It's a design process, and it's having everything, they're checked out before it's installed, and everything very well taken care of before filters are installed and all of the ducts are installed. And we use low VOC adhesives for these ducts. I mean, it's a whole process. It's a whole process. And basically, these are like the main reasons of what a green building is, and the difference between a green building by a conventional building. And I mean, you're taking care of the environment, you're taking care of the users. It's the whole thing all together. You don't see it as just, sustainable building, you're taking care of the environment and that's it. No. We take care of everything. It's the whole thing. It's everything. So this is it, guys. These are the differences between green buildings and conventional buildings. And I mean, it's a total art. This is art, and everything that we do, maybe not everyone is involved that directly with sustainability, but and sometimes I've seen projects where they're working in a sustainable project and they don't even know they were, what they're doing, but they're doing it, and they don't even know the purpose of it, but it's part of their job, it's part of what they're doing. And sometimes, what I like to tell, on-site employees is it's the actual thing and the purpose of why everything has a process and why everything is so strict in these type of projects, because we are taking care of everyone and everything, and we're taking care of the planet to have a less impact by constructing, have a less impact in the environment. Okay, guys, I hope this was useful. I hope you liked it. I hope you learned something today. This is the whole purpose of it, and I love to be here with you guys, and we'll wait for updates tomorrow. I'll be sending you guys some pictures of what I'm going to be doing in the project, and well, stay tuned. Hopefully we have more lives and things that you can share with me as well. And if you have any questions, go ahead. You're free. Go ahead. to make your questions. I'll be answering. I'll be there. Okay, guys. See you guys. Bye.